Okay, now that you've gone through the student guide for the Module 1 lab activity, I wanted to give you another video that's going to help you perhaps avoid stumbling on the lab quiz. Notice you have two opportunities to take the lab quiz. I do encourage you to uh, take it both times. Make sure you watch the video as well. And perhaps if you stumble the first time, you'll still have a chance to regain your balance on the second attempt. So the first question has to do with the celestial sphere. So for guidance on the first question, I encourage you to check out the celestial sphere, celestial equator, declination, and right ascension uh, tab. And check that out, and hopefully that'll give you enough information to handle both the first question as well as the second question. The third question is a graph that you need to interpret, and it does require a little bit of explanation. So where you would need to go to for questions both 3 and 4, my suggestion is to go to the Celestial Flat Sky Map Explorer. You're going to see a very similar layout to what you're seeing on the quiz. And what this Flat Map Explorer does is it puts the declination on the y-axis, and it puts your right ascension on the x-axis. One thing you have to really understand about this is that the right ascension increases from right to left. That's a little unusual for most graphs. Usually, most graphs, whatever's on your x-axis gets bigger when you go from left to right. That's not the case here, and I'll show you the different features of this map. So you can click on some of these things. I encourage you to click on the celestial equator first of all, and notice that is indeed 0 degrees declination. I also encourage you to click on the ecliptic. And notice the ecliptic is the path the sun takes during the course of the year amongst these background stars. These are all stars back here, and they don't move. No matter where, you can choose any star in here, click on it, and it's going to have a certain declination value, and it's going to have a certain right ascension value. And notice the way the right ascension value is given. You find what's called your vernal equinox. That is where the ecliptic intersects the celestial equator, going from south to north. Again, all winter, the sun is below the celestial equator. All of a sudden, it intersects the celestial equator at the spring equinox, or the vernal equinox, and then moves above the celestial equator during the summer months. So here's your vernal equinox. That's 0 hours right ascension. And notice the right ascension values go up as you move leftward here on the graph. And that's why this particular star has a declination of 39.6, and it's got a right ascension of 18.5 hours. So that's the way this operates. And again, you can click on the equinoxes and solstices to get more information. But again, that intersection point, the intersection points are the equinoxes. The vernal equinox is where the ecliptic goes from being south of the celestial equator to north of the celestial equator. The autumnal equinox is where the ecliptic goes from being north of the celestial equator to south of the celestial equator. That hopefully should help you answer questions 3 and 4. Moving on to number 5. Number 5, my recommendation is to check out either the orbits, and you can check out the orbits and light simulator, or you can also just check out the seasons and ecliptic simulator. Really your choice. You'll be seeing an image that looks sort of like this. It's going to be sunlight hitting the Earth. So you have two choices. The orbits and light might be a little more effective to answer this question. You get a chance to play around with the angle of your sun and the intensity of the resulting sunlight. Number 7, my suggestion is to go to the orbits, units of longitude and latitude tab, because it's asking you essentially a basic definition. For number 8, my suggestion is to go to the Terrestrial Flat Map Explorer. We played around with this in the student guide, so this should be fairly familiar. Again, it's somewhat of a definition sort of question, but again, your best bet is to go to that Flat Map Explorer for the terrestrial coordinates. For number 9, again, Terrestrial Flat Map Explorer, they're going to ask you to find a certain longitude value, I believe. So again, you want to go to this particular tab. All right, moving on to number 10, same thing, Terrestrial Flat Map Explorer. Number 11, my suggestion is to go to the units of longitude and latitude yet again. Number 12, go to the Terrestrial Flat Map Explorer again. For number 13, it asks, why is the summer warm in the northern hemisphere? Or vice versa, you could ask, why is the summer in the southern hemisphere warm? And it's really the same answer. So my suggestion is to come up with that answer, check out the Seasons and Ecliptic Simulator. That'll help you answer that question. Also, if you had the chance to build a solar motion demonstrator, that would be another way of answering that question. Number 14 asks about the shadows, the shadow on a stick. So again, you can go to Orbits and Light, or my suggestion is to go to the Seasons and Ecliptic Simulator. Again, here you can see the angle of the sun on a particular location on a certain date. In the Orbits and Light, you'll see a little guy standing here, and you can check out his shadow at different times of the year. But again, this is only for a mid-latitude northern hemisphere person. And so this may not completely answer your question. You may be better off seeing the Seasons and the Seasons and the Ecliptic Simulator to answer that question fully. Number 15, again, my suggestion is go to the Seasons and Ecliptic Simulator and ask about why the value of 23.5 is so significant. So think about all the ways that that 23.5 shows up in the celestial sphere. Number 16 asks about the vernal equinox. And finally, number 17 asks about the ecliptic. Both of those can be answered, again, with the celestial sphere, the Seasons and Ecliptic Simulator. And that's about it. So good luck. Again, one of the biggest stumbling points you're going to find is interpreting the graphs on pages, on questions 3 and 4. Once you figure that out, the rest of it should be pretty straightforward. Good luck.